When we go to multiply radicals, all that has to match is the order of the radical. That is, we can only multiply a square root with a square root, a cubed root with a cubed root, and so on. So as long as the order is the same, all we need to do is multiply the radicand. That's just the number under the radical sign. We already know how to do this. We've been working to simplify radicals by moving to the left here, by taking a product and separating them into two distinct radicals. Now we're just going to go the other way. The example on the left here is a quick one. The square root of 3 times the square root of 2. Because both are square roots, we can absolutely multiply them. All we need to do is multiply the 3 and the 2 together under the radical sign, and we get the square root of 6. For this second question, I'm going to show you two different ways to approach this problem. We'll start with the approach that will work in any case. So the number 3, not under the radical sign, that's just going to stay there. But the square root of 5 and the square root of 10 can absolutely be multiplied together. So we write 10 times 5 underneath the radical, or of course 5 times 10. There is no need here for me to switch the order. 10 times 5 is 50. The first answer we get when we multiply the radicals together is 3 root 50. However, the square root of 50 can be further simplified. Breaking 50 into 10 and 5 isn't productive for simplification because neither is a perfect square, but the square root of 50 can be written as 25 times 2, which is important because 25 is a perfect square. So we get 3 times the square root of 25, which is 5, times the square root of 2. The 3 and the 5 are regular numbers, neither is under a radical sign, so we can go ahead and multiply those, and our final answer is 15 root 2. This particular example has a second route that we can follow, and it turns out that it speeds up the process a little bit. So what I've shown you here will absolutely work for every question. This one has a shortcut. Again, I have 3 times the square root of 5, but then I notice that 10 is composed of 5 times 2. So I'm going to rewrite 10 as the product of 5 and 2. It's not helpful, again, for simplification because neither 5 nor 2 is a perfect square. Now I can write this as 3 times the square root of 5 times the square root of 5 times the square root of 2. The square root of 5 times the square root of 5, I could rewrite, I'll try it up here, square root of 5 times the square root of 5 as the square root of 5 times 5, or the square root of 25. And the square root of 25 is 5. So I recognize that if I'm multiplying identical square roots together, in other words, I'm squaring a square root, I just get the number under the radical out of it. So now we have 3 times 5 times the square root of 2. 3 times 5 is 15, so we have 15 root 2 as our final answer. So in this particular case, because we could rewrite one of our numbers, the 10, as a product of two values, one of which was the previous square root, turned out quite nicely that we could very quickly get to an answer of 15 root 2. But again, the left-hand side will always work. All you're doing is multiplying the numbers under the radical signs together under the same radical. And then we had to stop here and say, can I simplify the square root of 50? The answer was yes, and that's how we got to 15 root 2.